Under what conditions the lines whose three equations are given to us are concurrent? That means they meet at a common point. Okay, let us begin. First, what we'll do, we're going to name each of the three lines as the line L1, L2 and L3. So we consider the line 1. This is going to be the first equation, y equals to m1x plus c1. Now what we'll do, we're going to rewrite this equation as m1 times x minus y plus c1 equals to 0. So what we're doing here is we're writing the equation of the line in the general form. Then we're going to consider the second equation as the equation of the line L2. We have m2x minus y plus c2 equals to 0. And then finally we have the third equation of the line, which is expressed as m3 times x minus y plus c3 equals to 0. So these are the three equations of the line. Now we need to show the condition under which they are going to be concurrent. Now we know that if we want to show that three lines are concurrent, all we have to do is form a determinant using the coefficients of x and y as well as the constant term. And if we can show that the determinant is 0, then the three lines are going to be concurrent. So let's form a 3 by 3 determinant. So here we are going to consider a 3 by 3 determinant. That means a determinant that has got 3 rows, R1, R2 and R3, and it has got 3 columns, C1, C2 and C3. Now in the first row, first column, so what we'll do, we're going to use the coefficient of x of line L1, so that is going to be m1. Then in the first row, second column, we're going to use the coefficient of y, so that's going to be -1. And then in the first row, third column, we're going to use the constant term, which is c1. Now in row number 2, we're going to take the help of line L2. So here we will have in the second row m2, -1 and c2. And then in R2, we're going to use line number 3. So we have M3, and then we have -1, and then we have C3. Now we have to show under what condition these lines are concurrent. That means this is going to be equals to 0 if they are to be concurrent. Now we are going to simplify this determinant. So first what we'll do, we're going to interchange column 2 and column 3. Now that means C2 is going to be interchanged with C3 and C3 is going to come in the place of C2. But the moment we do that, the determinant is going to be multiplied with a negative sign. So we have -1 that is going to get multiplied to. So we have M1, M2, M3 in the first column. Then in the second column, now we have C1, C2, C3, and then the second row goes to the third column to make it -1, -1 and -1. So this is going to be equals to 0. Then furthermore, what we can do, we can take this -1 and multiply it to all the elements present in the third column, C3. So that means we are going to now get a determinant with the elements being M1, M2, M3 in the first column. In the second column, we have C1, C2, C3, and all the -1s in the third column is going to become positive. We have 1, 1, 1. So that is going to be equals to 0. So now what we can do, we can expand this determinant. So expanding is a very simple task. So this is going to give us M1 multiplied to C2 minus C3 minus C1 multiplied to M2 minus M3. Then we have +1 multiplied to M2 C3 minus C2 M3. That's going to be equals to 0. So now we have M1. So let's keep this as a M1 multiplied to C2 minus C3. Then we have -C1 times M2 plus C1 times M3. Added to, we have M2 times C3 minus C2 times M3. That's equals to 0. So we will now have, M1 multiplied to C2 minus C3. Next, what we'll do, we're going to take the terms containing M2. So this is the term, then this is the other term that contains M2. So we're going to take plus M2 as the common factor. So we are going to get M2 multiplied to C3 minus C1. And then we have positive M3. So we're going to take these two terms and take M3 as the common element. So we have M3 multiplied to C1 minus C2. That's going to be equals to 0, and this is the required condition which is going to make the three lines whose equation were given to us, they are going to be concurrent.